Okay, we made it to problem 3, which is going to involve some pre-processing and statistical modeling. All right, we're going to be reading in a data frame, and it's similar to what we've been working with, but with some additional information. So we have more information about students. This is going to come from a CSV file, and we're going to use our usual method of importing data from a link so we don't have to worry about downloading or uploading anything. Here's what the data frame looks like. Now, suppose we want to understand if these variables relate to some target variable of interest, and you might ask yourself, which variable would you want to try to understand, estimate, or even predict with the combination of other variables? And if you think about it, you might come around to the grade as the most reasonable target variable, sometimes called a response variable. So that's what we're going to do, and we're going to work towards that. But first, of course, we have to do some preliminary steps to make sure the data is in a format that is suitable for modeling. Okay, so the first problem is going to involve doing some exploratory analysis, actually, looking at the quantitative variables and seeing if they are related. We can look at a pair plot to see the histograms and the pairwise scatter plots, as we did with that Gapminder data earlier in the class. We'll see a correlation heat map, and then we're going to pre-process the categorical variables so that they are represented numerically, which is something we have to do for a lot of the libraries that we work with. I think you can be a little bit flexible with the stats models library, but this is a really good thing for us to work on. And I'm actually going to add to the comments here that we're going to be looking at the absences as well as another quantitative variable. Okay, so let's go through the steps. And first, I'm going to set up a data frame for just the quantitative variables. This is a common step when we want to look at patterns in the data. So we'll reference the only function parameter, which is df. This just takes in a data frame, and then we modify it throughout the function. So 2 sets of square brackets here, and then we do this when we're selecting multiple columns from a data frame. Again, just conforming to all these different libraries that we're asked to use and get used to. So we have hours studied. All right, so we've got that. Let's just run it to make sure we don't have any errors. Yeah, well, I can't do this yet because I haven't output data frame, but that tells me that I don't have errors in the function. I just have an error in how I'm using the function. So we'll get around to fixing that. Okay, let's create the pair plot from those quantitative variables. It really only makes sense to do this for quantitative data because the pair plot gives us histograms, or plots, which are also for 2 numerical variables. So we'll do our pair plot for the quantitative data that we just created. And I like to use the corner equals true argument just to see the lower corner, because otherwise we get redundant information. Let's just look at this without using the .head method. I'm getting an error because this is not returning a data frame yet, but we will get to that. So let's see what we do get. Pair plots can take a while to build. Okay, so it's not the largest data frame. We can see that as absences increase, it looks like the grade decreases. Not much of a correlation between hours studied and the grades, and yeah, not much of a correlation between hours studied and absences either. Okay, so a little bit of information there. Let's make the correlation heat map to quantify those relationships with the correlation value. I'm going to add some extra features to this. So we're going to do correlations for the quantitative data. And for that, we can use the core method, which is part of pandas. Okay. Something I like to do, once again, to just see the correlation values once and not replicate it across the entire grid, is I like to set up a mask, and that basically just overrides the upper corner of the correlation heat map. And so I'm going to apply that mask when I create the heat map. So let's create the heat map with Seaborn, and we'll graph the correlations that we created above, and then I'll set the mask equal to the mask that I just created. One thing I'm adding to this is annotations, because I like to actually see the values of the correlation so that I get, two pieces of information. I get the color that indicates how strong the correlation is, but I also get the value as well. I'm going to use a specific color scheme. This color scheme ranges from blue to red, which I think is good because then we can see the negative correlations and the positive correlations distinctly. I'm going to format the correlation values with 2 floats, so 2 decimal places, so we don't have excessive significant figures, and then square equals true. This just makes the tiles square. So some customizations here. And let's add a title. So a lot of this is extra. Our auto tests don't check for labels on the graphics, but I did want to use this opportunity to show you some things that can be useful as you move ahead with your Python trajectory. And then we're going to show the plot. So from the PyPlot library, we'll use the show method to make the correlation heat map visual. Let's see if we got it. Okay, that's good. I like this because, the colors and the values help me kind of understand the nature of these correlations. Okay, great. All right, now really important stuff that remains is pre-processing our categorical variables on this. So what we can do here, and this is not something we used very much, we saw this in some of our statistical modeling exercises, but I want to explicitly go over this. We're going to use a method called the getDummies method from Pandas. So I'm setting the data frame. Anytime I do this, right, when I say df equals something, I'm basically setting the data frame equal to a modified version of that same data frame. So you'll see the use of this getDummies method applied to the existing data frame, which is also called df. So when we do this, we're going to get a new version of df. Okay, and what variable do I need dummies for? I need dummy variables for this subject. Okay, let's look at our data frame. Right, here's the subject. Okay, so the subject is not an ordinal variable, so it's not like low, medium, high. It wouldn't make sense to code this as 1, 2, 3 or anything like that. It's also not binary, meaning there's more than 2 categories, so I can't just use 0 and 1. So instead, I'm going to create dummy variables, which will create a new column for every category of that variable. So there'll be a column for math, a column for English, a column for science, and then I'll get either a true or false if the subject is one of those, right? So if it's the math column and it's the first student, that student would have a true for the math column and a false for everything else. And then the next student would have a true for the English column and a false for everything else. Another common practice that we do when creating the dummy variables is we do something called drop first, which I will explain. Let's get the columns equal subject, right? Okay, following the syntax. So columns equal subject. I use the drop first equal true. And this is important because however many values you have for a given variable, if you include all of those values, right? Say there's only 3 subjects, math, English, and science. You could perfectly one with the other two. For example, if you knew that a certain student had false for math and English, then you know with certainty that the subject was science. Okay, because every row has a subject, so that would be the only possible value. So that's actually a case of what we learned about. It's called multicollinearity, where the variables are related to each other, right? The predictor variables are related to each other. So the drop first equal true is a way of eliminating that problem of multicollinearity. You can always determine the one unknown value from the other two or three or however many there are. So we're going to drop first equal true. And that should do it for the dummy variables. Okay, lastly, we have another change to make, which is to the extracurricular participation. And that is a binary variable. It's either a yes or a no. Okay, so when we have that scenario, for simplicity, what analysts will do is create what's called a map. Let me just copy this. Same thing, I'm going to reset the values in that column, the extracurricular participation column, to zeros and ones. And the best way to do that is with what's called a map, where we create a dictionary of the existing value, which is yes, and we want that to become a numerical value 1. And then we have a key of no, which is the existing value for extracurricular participation. We want that to become a 0. So now the variables are coded numerical terms, which makes the data frame suitable for analysis and statistical modeling. So this, for me, was an important thing for us to take a look at this stage in the class. So you have an example of converting data in a way that makes it available and usable in a statistical modeling process. Like I said, I think you can get away with it with stats models, but this is a good practice to work with. Okay, so let's run that new code. And let's also check the pre-processed data. Okay, good. We've got our graphs, we got our heat map, and now we have our data. Okay, so one of the subjects was dropped. So English was dropped. Okay. That is actually the end of that problem. In the next problem, we're going to now fit a model to try to predict grades using this pre-processed data frame.